Is science objective? What does objectivity mean? And you'd be surprised the answers I got out there. Anyways, we start out with our science critic because he was the one who kind of introduced the subject for us today. And that is, I showed him a little video in which we have an astronaut falling to Earth. And I told him the reason, the cause, the mechanism, right? The reason the astronaut falls to Earth is that every atom in his body is physically bound to every atom on Earth. And I illustrated it for him, and I explained the mechanism he is watching. Okay, so not only did I illustrate it, listen carefully, I illustrated it, and I also explained what he was watching. You got that? This is what he said. This is what he answered. So let's go with what I showed him and how he answered it. Here it goes. Give me a second. Listen carefully. If I explain that an astronaut fell to Earth because every atom in his body is bound to every atom that comprises our planet, all participants should be able to explain the same mechanism in their own words.
That is not objective. That is an idea that you have come up with that could be wrong. And actually, in all likelihood, that idea probably is wrong.
So this fellow thinks that it's got something to do with wrong and right. Objectivity, whether something is objective, seems to be related, according to him, to what is wrong or right. You would think that wrong or right are opinions. What is wrong for you might be right for me, or vice versa. That seems to be subjective. But in his mind, he thinks that is objective. Okay? So let's see what Fingernails has to say. Here he says the following, or this is essentially what he's saying. He's saying, objective, what is it? He says, subjective idea you came up with. So because I came up with an idea, that's subjective. Makes no sense to me. Objective, he thinks it's an opinion, right or wrong. If it's right, if it's correct, apparently that's objective to him. If it's a wrong idea, then it's subjective. This is the notion he's got in his mind, okay? And so, we can summarize because we can look at the definitions I looked at the other day, the ones that I put up there, and let's look at them again to see what objective and subjective mean. And again, these are defined by dictionaries, ordinary people who never learn how to define words. And so they have 10 definitions for objective and 20 for subjective. And so they have all these notions, and people sometimes pick one notion, the other person picks up another notion. And so nobody knows what objective means or subjective means. Why? Because there's so many notions of what objective and subjective mean. And therefore, people just pick up whatever they're interested in, whatever caught their attention or whatever went through their ears or their eyes. Okay, so here it is. Objective, you look it up, it says not influenced by personal feelings, interpretations, or prejudice, based on facts, unbiased, and objective opinion. Dealing with things external to the mind, rather than with thoughts or feelings as a person or a book. Belonging to the object of thought rather than to the thinking subject. And existing independent of thought or an observer as part of reality. So we have these different notions that define what these people think is objective. Subjective essentially is the opposite. Okay? What do I say? I say objective, free of interpretation. Clear, cut, we stop there. Period. Free of interpretation. What is subjective? Belief and opinion. Okay, so I define it concisely, clearly, I hope. And people say, well, that's not clear, Bill. Not to me. Okay, so let's work on it. Let's see if we can make it clearer. Okay. And what I show is a pulley. This is what I showed last time. We're going to show a pulley here, and it's going to have this rope tied around the pulley, okay? And it's going to pull a box up. Very simple. So I ask the $1 million question. Really, it's a 10-cent question. How did the box come up? What raised the box from the floor upwards? And what you're staring at, what is objectively in front of your eyes, is a rope that is moving, and the rope is going up, and it's tied to the box, and the box comes up. Very simple. Here it is. Okay? What are you staring at? What are you watching? This is the only question. What is in your field of view? Do you see any human? Do you see any machine? Do you see anything other than a rope tied around a pulley, tied to a box, and the box is moving up? Apparently because the rope is being tugged from one end by something or someone. That's what you're seeing. So we don't know what's pulling on the rope, but what the images are showing you is that the rope is pulling on the box. Okay, I think it's very straightforward for kindergartners. Some people have a lot of problems with it. They don't understand why the box is being pulled up, and we're saying the rope is pulling on the box. That's what you're seeing in front of you. This is an objective explanation of the mechanism that pulled the box upwards. Okay, so I show him something else. I show good old Felix here, and he's going to throw something through a window. And I'm the theorist, and I'm going to tell you how the window broke. And I'm going to say to you, this is my theory, this is my explanation, this is the mechanism I propose, and I'm going to illustrate it for you so that you understand it perfectly well without any doubt, that what went through the window is a horseshoe. A horseshoe broke the window. Now, how difficult is that? Well, for some people, it was incredibly difficult. They can't understand these kindergarten things. So here's my theory of how the window broke. I'm illustrating it. And if you have a mental defect, a mental problem, I explain it for you and tell you in your face that what I am proposing is that a horseshoe went through the window. Here's the images. Okay? Here it goes. We have a horseshoe. Good old Felix winds it around, throws it. Now, what did you just see? Let me show it again because some people still have problems. Here you have it one more time, okay, just in case you missed it. Horseshoe goes through a window, breaks it. Okay, that's my theory. Now, people say, well, I don't know what happened. Now, you just saw it. I mean, if you have eyes, maybe if you're blind, of course, you probably would not understand. Maybe you would have trouble understanding. Okay, but what I just showed you is a horseshoe going through a window. And if you did not understand that, which is kindergarten stuff, I tell you so that you can listen that my theory, that the explanation, the mechanism I'm proposing is that a horseshoe broke the window. What did I just say? A horseshoe broke the window. I illustrated, I explained it. And these people say, I don't know how the window broke. How you propose that the window broke. That's the issue, okay? What your theory is, Bill. I don't understand your theory. Okay, so what does this fellow say? He says, there was a bullet that broke the glass. 70 seconds before the magnet hit the glass. You are wrong because your eyes are too slow to recognize the mechanism. I didn't see a bullet anywhere. But even if, what this guy says, he says, there's a bullet, I'm telling him what the theory is. I'm telling you what the mechanism, I'm saying it was a horseshoe that went through the window. And he said, no, it was a bullet. Well, where did you see a bullet? It's not in the images. And I'm telling him that's not my theory, that it's not a bullet that I'm proposing. And this guy insists that it's a bullet. So I don't know what he saw. Maybe he's got special eyesight. I don't know. But even if he's got great eyesight, Superman eyesight, he can see these things. It's not my theory. It's not the one that I explained. It's not the one that I illustrated. And I'm explaining what he's watching. I'm saying it's a horseshoe, and he insists that it's a bullet. And then I ask him, well, how did the pulley go up? The box go up through the pulley, with a rope tied around the pulley. And he says, wrong again, Bill. We are actually moving down at the same rate as the pulley, as there is a motor inside the stationary box pulling the pulley down towards itself. Where did he see this? I don't know what these people have through their tiny brains. It's just unbelievable. I showed him a box being pulled by a rope that's tied around a pulley, and he comes up with all this nonsense. Where did he see this? And I'm telling him how the box went up. I'm saying, look, the reason the box went up is because a rope is pulling on it. That's the mechanism. That's the theory that I'm proposing. And he's changing my theory. He said, no, Bill, that's not what you said. There's a machine there and blah, blah, blah. Okay, here we have another bird brain. Says, Felix could be throwing the horseshoe while someone else smashed the window. Did you see anyone smash the window in the pictures that I showed? I thought it was just a horseshoe going through a window. But he says there was someone that smashed the window from the inside right before the horseshoe hit. I didn't see anyone. I hope you did too. But anyways, that's not my theory. That's not my mechanism that I'm proposing. I'm proposing that a horseshoe went through the window. You say, no, Bill, you're wrong. Your theory is that someone broke it from the inside before the horseshoe hit it. He's putting words in my mouth. He's saying, this is your theory. This is the one you're proposing. This is the mechanism you proposed. So the window did not break because the horseshoe flew it. You never know for sure. Yeah, I guess with all these mental cases, you never know for sure. Okay, how about the pulley and the box? Well, he says, let me get it. Went on the other side. It says something about a motor, I think. He says, you're wrong again, Bill. The mechanism that pulls up the box seems to be someone pulling the rope. Did you see someone? I mean, I didn't show someone in the movie that I showed, and I'm telling you that the rope pulled on the box because I'm just telling you that the rope is the one that pulled the box up. I'm telling you this. I'm saying what the mechanism is. I'm explaining what you're observing, what you're watching, and this guy says that he saw someone pulling on the rope. I didn't see anyone. Well, I don't know, but still, that's not my mechanism anyways. But that's subjective. It could also be a motor inside the pulley. I don't know. I didn't see any motor, okay? Have you checked? No, I didn't check because it's my theory. See, it's my mechanism, the one that I'm proposing. Science is objective, and I'm telling you what the mechanism is so that you understand my theory, the mechanism I propose, and I'm showing a rope pulling on a box, and you're telling me that my theory, that the mechanism that I'm proposing is that there's a motor inside the pulley. Well, I guess you know more than me, because I didn't show that, but, if that's what you saw and that's what you believe, So since you have ruled out this possibility from the beginning of your assumptions, your assumptions are only observations based on interpretation, based on previous experiences, so very subjective. So he thinks it's subjective because what he saw was that something different than what I explained and what I illustrated. Unbelievable. Here's another fellow, and we had a lot of these fellows. They're all experts, You could wake up from a dream to see that Felix never threw the horseshoe and the window is not broken. I don't know what he saw, but I saw, what the movie showed objectively, because that's what we're talking about here. Objectively, what we showed is a horseshoe going through the window. And I explained that my theory, my mechanism, when I propose, is that a horseshoe went through the window. And he says the window never got broken. So maybe he slept through the moment that the horseshoe went through the window. I don't know. He was sleeping, maybe. He didn't see that. Another fellow says, so if subjective is just a belief opinion, then objective is just a belief or opinion. So for him, it's the same. He doesn't see any difference between subjective and objective. It's all the same to him, It's no different to how you think knowledge is just a stronger belief. So he thinks that objective and subjective are both synonyms. They're both belief and opinion. And I guess objective is a stronger version of subjectivity. I don't know, stronger opinion, stronger belief. Do you get the same meaning the presenter is trying to showcase? Do you get what he is proposing? Yes or no? Well, the issue here is that we stare at something. We look at something. Here. Let me give you an example. What do you see there? You see a rope. That's what I'm showing. Okay, this is objective. I'm showing a rope, and this person comes and says, "Now you showed a unicorn." No, that's not what I showed. I showed you a rope, but he said, "No, you showed me a unicorn." And I'm telling him, "Look, this is a rope." And he said, "No, it's a unicorn." So either he's got problems with his eyes, or he's got a problem with understanding, because I'm showing him something. I'm telling him what he's looking at, just in case he missed it. And he still says it's something else. So he says, I interpreted, I believe you have something else. This is the problem, okay? What you watch is objective. What the screen shows in your face had better be objective, and everybody who has eyes in the universe had better see the same thing. What comes out of a screen is always objective. And if in addition, I explain what I'm trying to portray there, what I'm trying to illustrate there, you should have no problem reaching the same conclusion. We should all have the same interpretation. There should be only one interpretation. For sure, I cannot lie to myself and say, this is a rope. And then I say, well, by the way, that wasn't a rope. No, it's either a rope or it ain't. Can't be both. I can maybe lie to you, but I can't lie to myself. Hopefully, if I show you a rope and think it's a rope, and I'm going to give you my explanation based on a rope. I better at least be sure of what I'm showing you. Okay? And then it comes to you. If you interpret something other than a rope that I'm showing you, well, then you got a mental problem. You got to see, a psychiatrist. Shrink. Okay, I think the same fellow last time he said, is objective as in its agreed upon meaning? No, it's got nothing to do with meaning. It's got nothing to do with agreeing. In science, we do not agree. I don't know where these people have their tiny minds. They're flying around, My God. Another fellow, that's what I like. He says, subjected to 22 plus minutes in the moot court of words. These people think it's all semantics. It's all word wizardry, word salad. It goes through one ear and comes out the other for them. They say, I didn't understand any of that. I came here to do physics, not grammar. I didn't come here to learn, how to make sentences and definitions. I came here to do physics. And you'll see where this leads. He says, is that physics? Yeah, it's physics. What you call semantics, word salad, that's 150% physics. If you do not define your terms, you're talking nonsense, as you will see very clearly that this individual talks absolute nonsense. You'll see it in a second. Should be our objective authority. Has nothing to do with authority. It has to do with what you just saw on the screen. If you see the Mona Lisa, you say that's the Mona Lisa, that's a picture of a woman. And if you say, well, no, that's not a picture of a woman, that's a snake. Well, then you got a problem, either with your eyes or with your understanding, okay? He says the cartoon describes the mechanism, but only my theory is objective. No, it's not that my theory is objective. I'm trying to explain to you my theory. What's objective is what I'm showing you on the screen, and I'm describing or whatever what's on the screen so that you understand my theory, so that we're all on the same page. And if you don't understand the theory, I go one further step and try to explain in more detail until you do understand my theory, not your theory. We don't care about your theory. Right now, I'm the presenter. I'm the one who's showing you the movie of my theory. I'm explaining to you my theory, and you're saying you don't understand it. Or you say that, oh, you're an authority. No, I'm not saying it's an authority. I'm giving you my version of how the universe works. That's not an authority, because authority has to do with belief. I'm not asking you to believe it. I'm asking you to understand it. These mental cases, they don't understand any of this. Okay? It just goes through one ear. And again, because they think it's word wizardry. Even without an explanation of the theory or mechanism. And again, he thinks it's a question of authority, and I don't know what's going through their tiny brains. Okay, so, but let's go through what this fellow proposes. He proposes dialectric. He says this is the solution to all these problems, And so he says the answer is magnetism in its consubstantial dielectric force. And I'm going to digress for a second here, just take a little tangent just to address this, because it shows why these mental cases, because that's what this person is. He's a mental case. These people, they use words that they do not understand. And one of them is dielectric, of course. The other one is magnetism. They think these are physical objects. So they're going to explain their theory using magnetism, using dielectric. They say, oh, the dielectric moved in this direction, moved up and down. They do everything with a dielectric. They use this word dielectric for them. It's a mystical word. And so here it is. This is how what dielectric is. We look it up, and here it is. What are dielectrics? Dielectrics are materials that don't allow what? Current to flow. What does current flow mean? It means that they are saying that the electrons are moving from atom to atom, as you see there on the right. It's illustrated, okay? They are more often called insulators because they are the exact opposite of conductors. But usually when people call insulators dielectrics, it's because they want to draw attention to a special property shared by all insulators, polarizability, okay? So they're talking about polarizing. They have a positive and a negative. That's all they understand. There you see it on the battery, a positive and a negative, and you see the little electron bead bouncing around. Okay, and they call this nonsense dielectric, and that's what they're going to do their theory with. They're going to do it with current flow. And of course, they cannot explain they cannot describe really what their atom looks like. What is the atom? Is it a little proton in the center with a little electron bead moving from atom to atom? Is that what electricity is? Current flow? It says when a battery is connected to a conductor, the potential difference, whatever that is, right, of the two poles of the battery pushes on what? On all the charges. How do you push a charge if a charge is 1.6 times 10 to the minus 19 coulomb? In other words, charge is a number. It's a quantity. And they're going to push a quantity. And this fella's, he's got these brainwashing since he was a kid, and he doesn't understand any of this. How do you push a charge in physics? We're not talking about math here, we're talking about physics. So he's going to push a charge in the conductor. He's going to push a number in a conductor. Great. Which in turn causes them to what? To drift slowly through the material, creating a what? A current through the conductor. So they're going to have this current, which is a word that we use for rivers, like the current. And they're going to have this current flow. And what is this current flow? It's the pushing of charges. Okay? They call this whole thing dielectrics. Okay? Electrons can wander freely. That's what current is. According to the establishment, this is what this person learned by heart. Okay, he just memorized it, so he uses the word dielectric. It says, in a dielectric, the electrons are stuck inside atoms, and so current doesn't flow at all. So what is an electron? It's a little bead that is stuck inside the atom. And for some reason, sometimes it flows, which we don't know why, what pushes it out of the atom or pulls it out, right? And so current doesn't flow at all. So these people have this notion that you see there at the bottom, where the electricity is just a flow of electron beads from one planetary atom to another. That's their notion. And from this, they get this word called dielectrics, and that's what they're going to do their, you call it physics? They're going to do their physical interpretations with this nonsense. The electric field, okay, field, what is a field? Exerts a force, a field, a concept, exerts a force. It pushes a wall. That's great for fields to push on a wall, right? And it's going to exert a force on what? On the charges. So here we have a field exerting a push or pull on a number. Oh, great. This is what they call dielectrics, all this nonsense. The individual electrons remain tied to their parent atoms. The electrons remain leashed to atoms by what? The electrostatic forces. So we have this thing called a force, whatever that thing is. I've never seen a force. I guess it looks like a tether, whatever. And it leashes the electrons to the atoms. So with all this nonsense, of course, this person says, Bill, we can explain all this with dielectrics, okay? And so, this is how they do their so-called physics. They use words such as force, field, wave, ether, plasma, and dielectrics. And they think of themselves as intelligent first, let alone the fact that they think of themselves as physicists. They think they know how this universe works, and they're using all these concepts as physical objects. So yeah, we do need to define these terms to find out what they mean. And this person never came to, to figure out, never analyze what he's talking about. He's just using these words. Oh, the dielectric. But then he says, I do word salad, right? Yeah. Okay, so here's the summary by one fellow who I think did a pretty good job because he synthesized and I think understood it quite well. So here it is. He says, you want to define something, referring to the Universal movie, right, called a static concept. So you simply define a thing called a frame as a result of a universal pause button. We pause the button. Why? So that we can see the objects before we move them around. Okay, we look at the static concept and we look at the object. We want to see what's in a single frame before we move anything around. You can't put dielectric in a single frame. And of course, people like this fellow doesn't understand that. It's beyond his capability. So yeah, we have a horseshoe there. Okay, that's what I have to show you first. I showed you the horseshoe. So you say, look, this is a horseshoe. Okay, now you've seen the horseshoe. Now I said, look, this is the mechanism that I propose for how the window broke. And that's the horseshoe went through the window. Now, how complicated is that? Okay, and again, we have all these people who say, no, it was a motor, it was, who knows, they come up with all this nonsense. So if I show you a horseshoe, you're not going to say, well, what he showed is a unicorn, or he showed Superman. That's what went through the window, or it was a rock. No, I'm showing you a horseshoe, and I'm telling you in your face that it's a horseshoe that you're staring at. What's your problem? What is it that you don't understand? That's objective. When what the screen shows you is objective. Now, if you have trouble with seeing, then you have a problem with your eyesight and your understanding. You are subjective, not the screen. The screen, it just pushes out stuff into your eyes, and that stuff should be the same for everyone in the universe. Any Klingon who comes and watches the movie should see the same thing as you do. That's called objective, what comes out of the screen. If you didn't understand the mechanism that you just watched, the theorist comes in and clarifies for you, look, this is what you just watched. So if you're missing something in there, I clarify and fill in the blanks so that you understand completely what my theory is. And after watching, and I explain to you what you're watching, you still say, well, no, Bill said that Superman went through the window. Or someone broke the window before the horseshoe did. Okay, so this is where the problem is with all these people. Okay, so here we have it. This is the Universal movie. And in any frame, all you have is location. You have distance between all matter. And the first thing we do, at least within a frame, is define the static concepts that you see up top. Those are the most important ones in physics to give a physical interpretation to any phenomenon. And we have the word object. That's all we have, objects. We call it matter. The whole set of objects out there, we call it matter, the ones that exist. Okay. We have between the objects separation, we call it distance. We have the set of distances for any given object, we call that location. That is the location for that object with respect to all other atoms or all other objects in the universe. That's the only thing Mother Nature and Father Universe understand, location. They don't know how many meters, they don't know how many feet, They don't know how many kilometers or miles. All they know is that this atom or this object is separated from that object. That's all they know. Okay? And then we have existence. Whatever exists is only in a single frame. All the other notions, such as, there you see them at the bottom, motion, plasma, ether, and so on, dielectric, we should put in there so that these people don't commit such gross errors. All those are dynamic concepts, and we can't get to them until we understand the static ones first. All dynamic concepts are built upon static concepts. You need to define, absolutely need to define static concepts before you can move on to dynamic ones, because dynamic ones are founded or are defined in terms of static concepts. Okay? So here, let me give you an example of why we have problems with all these people who do not understand what objectivity is. This is Mr. Einstein, and he proposes something that you see on the screen. Let's get this right, okay? You're going to watch something on the screen, and that should be objective. Everybody should see the same thing, because, if you want, I'll show it to you 100 times until you see the same thing as everybody else. So we're all going to watch something, and we're all going to see the same thing. That's objective because we all saw the same thing. Not because we interpreted the same thing, but because what the screen showed us is the same for everyone. Let's get that right. That's objective. And if you did not understand what you just watched, it wasn't clear to you, then Einstein comes in and he's going to explain what you just watched. So you have no excuse not to understand after watching and having the theorist, Einstein in this case, tell you what you watched. You have no reason not to understand it, especially if it's a simple concept, a simple mechanism, right? A simple theory. So here it is. This is Einstein. He's going to explain to you general relativity, how gravity works. Here it is, okay? All for you, okay? Einstein says, look, there's a net, a fish net. We can call it a canvas if you want, no problem. You have this fish net, and we have a ball rolling around it. Do you see anything else on the screen, other than Einstein, obviously? Do you see anything else on the screen? What do you see? What is objectively there in front of your eyes? Well, hopefully you see some kind of fish net or something that looks like a net of some kind, right? And you see a ball rolling around. Okay, that's what's in front of you. Now, if you see something else, if you see Superman, if you see a unicorn, I can't help you. You have problems that you got to see an ophthalmologist. Okay, but what's in front of you is a ball rolling around a net. That's what you see there. Okay, so now Einstein explains, look, what you're staring at is the Earth rolling around space-time. Okay, so far so good. He's saying, look, that net represents space-time, and the ball is the Earth. And the reason the Earth goes around is that something is either pushing or pulling on the net downwards, and then the ball, in this case the Earth, is pushing against the sides of the net, and it doesn't get away out of the solar system, obviously, right? That's the idea. That's the explanation for why the Earth goes around the sun. Okay, so it's very clear. Something pushes or pulls the net downwards, and the ball, the Earth, does not fly out because it's rolling around. It's pushing against, or being pulled, I guess, from the outside. It's pushing against or pulled out towards the net and cannot escape that circular motion. Okay, that's the theory. That's the explanation. That's the physical interpretation of relativity for gravity. Okay, now what is the problem with this? The problem with this is that this is not objective. It's not objective not because the image is wrong. The image is no problem. We all understand the image. It's not objective because Einstein is telling you that what you're staring at is not a net. It's space-time. It's a concept. He's saying that time is warped. He's saying that what you're staring at is not a net, but warped time. Well, I got a problem with that. See, I got a big problem with that because that's not what I'm staring at. What I'm staring at is a net. I'm not staring at warped time. Okay, so this is where the problem is. There's an inconsistency between what Einstein has illustrated and what he is explaining that you are observing. So he's cheating on you. He's lying to you. He's misleading you. He's saying, look, what you're staring at is not a net, which is exactly what I'm staring at. He's saying what you're staring at is warped time. So there's an inconsistency. This is not an objective theory. It's not even, you could say it's subjective. In other words, the subjective explanation does not match the objective images that we see on the screen. There's a disconnect there. That's the issue. So the theory is not objective. It's not a scientific theory because all scientific theories, physical interpretations, mechanism, they have to be objective. What you see is what you get. You cannot say, this is what I saw, but this guy says, well, what you saw is something else. No, no, don't tell me that. I have my own eyes to tell me what I saw. Okay, so don't tell me what I saw. I already know what I saw. Just, you can fill in the blanks if I miss something, but don't tell me I'm watching warp time. What I watched, what I saw is a net, a fish net, a canvas maybe, whatever. Okay, so I hope you understand what the issue is here, what the difference is, okay? And of course, what they do in general relativity is say, well, the famous cartoon where they say, understanding gravity, space-time, right, is like a rubber sheet. Like, they're going to use an analogy, right? Massive objects, what? Distort the sheet. And so the student says, hold it, they distort it because they're pulled down by what? Good question. What physical object is pulling it down? And the teacher says, oh my God, no, this is simple, is it? Space-time is like this set of equations. But that's not what you illustrated. You did not illustrate an equation. You illustrated a net or a canvas or a trampoline. And you put a bowling ball on it. That's what you illustrated, but now you're saying that's an equation. Now, I got a problem with that. That's not an equation. That's not even an analogy for what you showed on the screen. Okay? So this is the problem. The problem is that the explanation, the descriptions, they don't match what they're showing. There's a disconnect there. So it's not an objective theory because what's being explained or described does not match what is coming to your eyes. There's a disconnect, a complete disconnect there. Here's another example, very famous experiment example. And here you see it. A particle can be at two places at once, according to quantum mechanics. And there you see it. So what are you staring at? Well, I'm staring at two particles. That's what my eyes show me. I see two particles. And they say, what you're staring at is one particle at two places. Well, no, that's not what I'm seeing. I'm seeing two particles. And so they want to make you believe something they cannot illustrate. They cannot even illustrate. And that is that a particle being at two places at once, two different places at once. They cannot illustrate it because what you will see always is two particles. That's not what they're describing. That's not what they're explaining. So there's a disconnect between what you see and what they're telling you in your ears. The sight does not match the ear, the hearing. That's where the problem is. And they don't match. And of course, then you have people like Juanito Baez. And he, professor at one of these universities, he says 10 points. He wrote this in his crackpot index. He says 10 points for arguing that while a current well-established theory predicts phenomenon correctly, it doesn't explain why they occur or fails to provide a mechanism. Yeah, because what happens is that, so he takes 10 points off of you or gives you 10 points for being a crackpot, right? And yeah, they cannot explain the mechanism because if what they show does not match what they're explaining. There's a disconnect, a complete disconnect there. And this is the issue. The issue is that their explanations don't match what you're seeing. Now here comes Bill Gaede, and he comes up with something different, and he shows the following. And he says, look, what you're staring at is two balls. Those are atoms. They look like balls in real life, and they're expanding and contracting. And by doing so, they torque a rope-like entity, twined pair of threads, that physically bind them. And those torsions is what we call light. Now you cannot say this is not objective because what I just explained is what you're watching, what you're staring at. I'm not saying, look, what you're saying is what you're looking at is an equation. Okay, you're looking at a unicorn. No, I'm telling you what you're staring at. I'm just saying, look, we have two atoms. They're expanding and contracting, doing their quantum jump, as it's called. They're bound or connected by a rope-like, DNA-like entity. And when they expand, they torque the rope. And torsion is light. This light is torsion along that rope, the propagation of this signal. So what I'm explaining is what you're observing. Now we have a complete connection between the explanation and what you're staring at. That's an objective theory. Okay? This is not subjective like the other people, which says, well, what you stared at is not what we illustrated. We illustrated this, but we explained something else. You did not watch or see a fishnet. What you saw is an equation. No. I saw a fish. That's what I objectively saw. And now they're saying, well, but you're supposed to make believe. Go through the motions of believing that that's an equation. This is the problem with what the mathematicians do. That's why what we have today out there is not objective theories, and therefore if it's not objective, it's not part of science. Science is 150% objective. Objective means that you have an image coming to your eyes, and hopefully you understand it just by watching the images. But if that's not enough, the theorist comes in and clarifies for you what it is you're staring so that you understand exactly what he proposes. Everyone in the universe should understand what the presenter is proposing. Now, you might have a different theory. You might say, well, I have a different theory. No problem. We don't care about your theory. We're caring about right now about the theory being presented by the presenter, by the person who's giving the presentation. Okay, so that has to be objective. There can only be one interpretation for what the theorist is proposing. There can't be 10 different interpretations for what one theorist is proposing, especially for a mechanism. Mechanism has to be straightforward. Otherwise, the machine doesn't work. My son says that in programming, you have to program it right because, you can't cheat. Whatever you tell the machine to do, that's what it will do because it follows a certain logic. You cannot have 10 different interpretations, 10 different channels for one mechanism. Otherwise, the computer doesn't understand. It'll follow whatever you told it to do. So it's kind of like forcing the logic. Everybody has to understand the same thing. And people have trouble understanding that. They think that objectivity means that I've got a different opinion. I've got a different way of doing this. It's got nothing to do with that at all. It's got to do with what you watched, what images were shown in your face. And if that wasn't objective enough because you did not understand it, because you don't have the capability of understanding what they just showed you on the screen, the theorist comes in and clarifies anything that you need to understand so that you understand his theory, the mechanism he is proposing. That's called objective. Science had better be objective, and all mechanisms, especially mechanisms, they have to be objective. They can't be anything other. And that's what physics is about, explaining mechanisms. You have to explain how Mother Nature runs her shop.